I'm Bryce Babinik. I'm one of the application experts and 3D printing technicians here with MLC CAD Systems. So I work out of Dallas where we've got most of our machines. And so I get the pleasure of working with the Fuse and Sift systems. So to give sort of an intro to SLS printing overall, it falls into a really interesting space where you've got, normally you can use FDM or SLA printing for one-offs or two-offs, and it's good for that. But as you hit that sort of mid to high volume production levels, they're not quite going to meet it, and it sort of fits just before injection molding, where it's not being used quite as much, where you can justify the tooling costs and everything there. So intro SLS, where we've got a system that uses plastic powder. And as you can see on the screen, it will melt that powder, the cross section of your part, into this powder. It'll bring a new layer across, and then it'll melt the next layer. And you can see how fast it's melting this whole layer. And so you can nest, multiple parts within it. You can, unlike SLA and FDM, you can have your parts up in the Z direction as well. So this is an option where you can print hundreds and potentially even thousands of parts in a couple of days, depending on the size of it. So it's a really nice system where you're taking, you can see where the part is in this, but you can see where all the powder that's not being turned into a part is. And this system actually recycles that unused powder, brings it back in, and now we're going to reuse it in future prints, future builds. So it makes it very cost effective, and it's a really easy to use system. So on my left, you all right, is the Fuse. So this is the actual printer itself. And then the way Formlabs have done it is they've actually separated out our sifting station where we're going to reclaim the powder. And so that's on my right side here. So we're going to start off with the Fuse. We'll do kind of a deep dive here and explain some of the different parts and features that we've got going on. We'll hop over to the Sift. And we actually have some parts that have been sitting there waiting to be sifted for a while. So we'll give you guys a quick look at what that process looks like. But yeah, let's dive into the Fuse. So this thing, like we said, it uses plastic powder. So we've got our hopper here on the right side. We've got this thing filled to the brim right now because we're about to kick off a pretty big job. Normally through this little window, you've got your different markings for how much powder is sitting inside, so you can have a rough idea just looking at it if you're going to have enough for your print job. There's also some sensors in there that know whether or not there's going to be enough inside of the printer. So this is our powder hopper. We also have a really essential part of this, which is our build chamber. So this is where your parts are going to get seated in. So we've got the build plate where it starts, and this thing moves down as the layers get moved across it by the roller. In the Z direction, we have a little bevel drive gear here. And so this build chamber actually doesn't have a motor inside of it. The motor is inside of the Sift, and inside of the Fuse, and there's a motor inside of the Sift as well. And so that's going to be what's driving this thing up and down. And the way that we communicate that with the printer and the Sift is going to be using this plug, which has a little holster. So we plug it in, and now the system's able to drive it up and down. It's able to track temperatures. It's able to heat the chamber as needed. So this is a really big piece of the system. And from there, obviously, we have the printer itself, and we've got the print chamber. So this is what it looks like without the build chamber in here. To add it, we just open this lock. We throw our build chamber in, lock it in place, and then again we want to connect this cable so the printer is communicating with the build chamber. It's able to heat it, and it's able to move it up and down. As part of this system, the most important part is keeping this thing really thermally stable. And the way that they do that is using multiple temperature sensors and heaters throughout the build chamber. We have our 2 quartz heaters up at the top here on the left and right. And so these guys are basically like light bulbs on steroids. They produce a little bit of light, but they produce a lot of energy. And so they heat this chamber up, and they do it in a really consistent way that's able to get the powder just below the melting temperature. And then from there, we've got a laser that comes in from the top. And we've actually got what's called the optical cassette. And so this is what the laser is shining through. This is what our camera is seeing through. So this is a piece that you'll take out and you're able to clean to make sure that we're getting full penetration with the laser through it without getting any obstructions from debris. So this guy keeps the camera and the laser protected. So it's just nice that that's a removable piece that we can work with. So this just slides back in and we'll lock it in place. And that's part of one of our pre-print checks. We want to make sure that that thing is nice, clean and clear. So the other piece of having a really nice thermally equivalent chamber is by using a sensor here in the top. So this guy, again, is one of your pre-print checks. This thing is just on a magnet, and so we can take it out. We can make sure that this thing is nice and clear. There's no obstructions before we drop it in place. See if I can find it without looking. And we've got a green light to let us know that that thing is in the right place. It's connected. We're getting our correct readings. And so this allows the printer to communicate with everything to bring it up to temperature, to make sure that it's stabilized across as the layers are being built and everything is heating and cooling throughout the printing process. So from there, we've got air coming in and out of this system, and we're going to filter it as it comes both in and out. So we've got our little filter chamber in the side here. This is perfectly safe to be run in our shop inside. There's a HEPA filter built into this to pull out any sort of contaminants. When the air is coming in, it's being heated, so it's not going to cool everything down as it gets pulled in. So we're going to maintain that sort of thermal consistency. So the way that we get our powder across this system, we've got our hopper on the right-hand side. Inside here, you can't see it from where we're at, but there is basically a cylinder with like a C shape cut out of it. And that cylinder is going to rotate, scoop up powder, and now our C shape, filled with powder is on this side, and there's a little flipper that comes in, pushes the powder in front of the roller, and then that roller pushes the powder across, creates a pretty even layer, and it deposits any excess powder on a hopper on the left side. And again, there's another flipper on this side, which will push powder up in front of the roller. Roller comes back across and gives you a really nice even coating of powder. So one of the special things about this system is it runs without an inert environment by default. So we can run this just in the regular, we don't have any gas hookup to this, and the way that the Formlabs system works, it keeps that powder from deteriorating even in air. But if you are using this thing and you've got some really high throughput, you can even connect up some nitrogen. You can get a nitrogen generator even and hook it up to multiple fuses, and you'll get better refresh rates. You'll have less degradation of your powder over time. So it's a really cool option that they offer. So coming into the sort of user interface here, we've got a really nice view of what's going on inside of the printer. And so we can monitor it as it's going. There's actually some AI built into this to keep track of if, say, there's a piece of powder that's come loose, or like a boulder of melted plastic that's come loose, and the roller's pushing it across. The printer will stop at that rate, and it'll save you from completing the print, so you're saving a lot on material. It also is able to see if you've been using this thing, next to a blasting cabinet, and some of the blasting powder gets in here. It'll let you know, hey, we don't think this print job should be completed, and you should basically vacuum out your system, and let's start with some new powder that's maybe not so contaminated. So one of the other nice things you get is, as you're kicking off a print, there's a couple of pre-print checks that we already talked about here, and you have to make sure that you go through these each time you send a print, but you can do this beforehand. We can click these, check them off, and make sure the printer is primed. And that way we can even just send it directly from a computer to the printer, and it'll kick it off. So now I can be at home and I could kick this thing off if I wanted to. Some of the other nice things is you get a print queue, and we're gonna actually kick one of these off here in a second. These are some SolidWorks rollout parts that we needed a couple more of than we thought. So we're gonna use it as an excuse to run this thing again for the webinar. And then We also get a nice screen that tells us, you know, about how much powder we have, whether or not we have a build chamber in there that's assigned to the correct powder. And we even get our maintenance checklist that we can see where we're at with our hours and when we're going to need to do some of these things. So really convenient and really nice. So this is from our print history. We're going to print the same thing again. So we're going to open this file up, and we're just going to go ahead and hit print. So this thing takes about it takes about an hour to heat up. So that's whether you're doing one tiny part or you're doing a big build. So usually you want to make sure you're packing this thing pretty full. You'll get a bit better cost per part that way as well. So it's convenient to pack it full. This one is pretty full, so we'll just run it, and we'll give it the hour to start going. And by the end, once we're finishing up, it may start to pull some powder across, and we may see some movement there. So we'll swing back to it. So the sift, one of the nicest parts about this system is your cooling time is about 30 to 50% of your print time. And so you don't want to have to leave the chamber inside of here for that whole time, because you could just be, cycling chambers throughout. So there's a stage when it'll let you know, hey, this is safe to pull out, and you can let it continue cooling in the sift or off to the side. And so at that point, we'll pull the chamber out, we'll put a new one in, and we'll come over to our sift system and start working with it. So the way this system works is it has a pretty big filter here in the back, and it's got a vacuum that will pull and create a negative pressure inside of here. So, I mean, you can see we've been running this thing for a couple of weeks, or actually a couple of months now, and we haven't done any cleanup. Specifically for this webinar, we wanted to show you guys, not because I didn't want to clean it up. There's almost no powder around here. This thing is really, really clean. They did a great job with that. And so, like I said, it's got the negative pressure. It's sucking all of the powders out that would be coming towards us. And so we're going to load our print chamber into the right-hand side. And you can see on the top of this, as you start to build these chambers up and say you have multiple jobs going, it's going to print the name of your build on top of it. So and you can distinguish, which one is which. So I'm going to take this thing, slide it into place. We'll again lock it into place, and then use the plug to connect it to our system here. And now on the screen, we can see that this thing is cooled down and ready. It's actually been sitting here for a few weeks. That's why it's a little bit cracked and shuffled around on the inside. But if you want to let it sit and continue cooling, you can just cover it to keep anything from getting in there. And so once you kick this thing off, we can move our print cake, so to speak, up. We can shift it over the sifting area, and all of the loose powder that's not part is going to drop down into a hopper that sits in here for used powder. On the right-hand side, we're going to have our new powder that gets added in to the top. And we've got our cartridge that sits down here in the bottom. So we can set up our refresh rates. So that's the rate that your old powder is going to be mixed with new. For nylon 12 that we're running, we want this to be about 30%. We've run this for a couple of cycles, so I may bump it up, maybe 40% this time. We'll hit fill, and that will allow the system to fill up the powder as we need it to. Once this thing is filled with powder, it doesn't mix as it's dumping in, it just dumps a certain ratio of each. So we'll want to close it off. We'll pull our cartridge out, and we can just slide it onto the side of the sift where we can kick off the mixer. And this is going to mix our powder really thoroughly. It just runs for 10 minutes. And then once it's finished, it'll stop, balance itself out. We can take our powder and we can drop it into the hopper. And this thing seals really well. And if you give it a few minutes, the powder is so heavy that it sort of settles down and it doesn't create any sort of plume. So we pull this off, and again, we haven't done any cleaning. There's almost no mess from this. So just a really convenient way to get your recycled powder back and forth. So drawer back in. We've got our cartridge ready to go. And at this point, I'll go ahead and sift some of these parts. These are actually a drill housing. Make sure I've got my gloves. For this part of the system, it's ideal to use gloves. The powder is not really toxic. It just kind of dries your hands out. And you also probably want to wear a mask. The powder is really heavy and it doesn't come up into the air and plume very much, but it's just always a good idea to play it safe and use a mask as needed. So let me glove up and we'll start depowdering this thing. This is something that was, super fun. It sort of makes you feel like a kid again as you go through and you feel like a little archaeologist. So they conveniently have a button on here where we can just press unpack, and now our powder just starts coming up out of the chamber. And we want to kick off our sift, which just starts, vibrating our system here. So it'll just encourages the loose powder to fall down into the used powder tray. There's also a vacuum built into this system, so it makes cleanup very, very easy. So we can vacuum everything that we don't need out of the way. And this vacuum is really easy to remove and use it around the fuse or whichever system you need to be working with it with. All right, so we've got our powder cake, so to speak, pulled up out of the build chamber. So I'll just try to shuffle this thing over. And now you guys can kind of see this powder is just falling down, and all this stuff that wasn't used, we get to reclaim it and we get to use it in a future print. So I'll get one of these brushed off pretty well, just to give you guys an idea, and then we'll hop into the software as well so we can see. So lots and lots of powder that we can reuse out of this. And we've got a really nice tool rack up here that we can take advantage of. Go ahead and start using one of the brushes, and you can see this stuff. You can start to see this drill housing, take shape. And you can get really close to finished part out of this, but we recommend usually going through and sandblasting your parts. It'll clean them up a lot better, and you won't have to worry about any of the loose powder. And for places that are kind of hard to get to, like some of these little nooks and crannies, some of the little holes, the blasting cabinet will work really well for that. Get the inside here. We've also picked up this little automatic Dremel, so for certain flat faces, this thing works really well. You got to be careful or it'll throw powder everywhere though. So one of the key things about SLS versus FDM and resin is that because the powder is supporting the part, you don't have to worry about supports. You can print some really intricate little shapes and features. You've got no supports going on. You can do print in place stuff really easily, and it's all going to come out just fine once you get the powder out of it. So get a really good view of your part here. Really detailed. Again, no supports. We've got full, ribs and everything going on. We've got probably functional holes here that we can tap into. So really cool system. Really good way to use it. I'll go ahead and move on to the software now. So just at a glance, this is the same thing. If you guys do any SLA printing, this is the same software. It's called Preform with Formlabs. And you just need to switch your printer type and your material, and it'll pull up your Fuse workflow and workspace. So this, by default, is going to give you the printable area. So while the system runs, for that thermal stability, it prints a couple of layers of powder first, a couple on top, and then it likes to have some space around the outside. But this chamber is giving you only the printable area, so you can push these things right up against the outside as you need to. You're going to get estimates on time. You'll get estimates on how long the chamber is going to need to cool afterwards. You also get your total powder usage. And when you hover over this, you're going to get an idea of how much powder is fused and how much is unfused. So that can help you calculate your costs based on how much is being fused. You know for sure you're losing that powder. You also get your packing density, and that'll help you figure out if you're maximizing your space and getting the most out of it. You get your list of parts. We can print multiple of the same parts here. We can print multiple different parts, and we can take advantage of some of our options to pack those as conveniently as possible. I'll run you guys through how you would set up an array. So if you're printing, let's say a couple hundred parts, or you need 30 to 50 or whatever it is, you can use the software. You don't have to upload that part 50 different times. We can use an array to create it and add it in there. So the part that we're going to be printing or showing off here is this ball valve cutaway. So this is a really cool sort of print in place item. And I can show you guys this here in a second. In real life, we've got one printed, but we can see the whole thing here. We'll want to bump it up against one of the walls, and we'll use our array models. And here we can just start growing this thing out in our X and Y, and we'll even bump it up in the Z. So now we can fully fill this chamber with just a couple of clicks. We have full control over how far these parts are spaced away from each other. And depending on which material you're using, you'll want to change this. For nylon 12, we can go as low as like 1 millimeter, but just to be safe, it goes to 5 by default. And you can just apply that. It's going to give you this whole chamber of parts, and you're good to go. Pack selected does a similar thing. If you're using multiple different models, it'll try to get them as close as it can and as tight as it can within the printable area. So here's the part that we printed. And it is, again, without the needing to use supports, we can have some really nice print-in-place type features. So this has a movable thread, totally functional threads, and just movable parts and pieces. So you can get some really complicated geometries out of this process. From there, you would just send your print to the print queue, and again, you can kick it off. So now ours is preheating, and we are actually getting some movement here. So it started to put down those first couple of layers of powder, just to keep it nice and safe. Okay, so cool. If you guys are interested in this and you want to, take your own deep dive, there's actually a totally interactive website here where you can click on each one of these features and parts, and you can get a close look at them. So you can do your own research. You can get a really nice view of how these different parts and features look. So we've got our heaters and all that good stuff. So definitely bookmark this website if you're interested and you want to see a little bit more. Thank you guys very much for coming out. We're happy to do this. It's been a lot of fun. Thank you, Chris, Ben, Marcus, everybody for being here. And we'll see y'all in the next one.